So guys, this is the third session for multi-threading. In previous session, what we discussed, we talked about what is the multi-threading, right? How we can achieve it multi-threading, what is the thread, and we learn in Kuch Java if you want to create a thread, what are the different approach of it. How many approach we have to create thread in Java? Two approach:
Two
extending thread
approach.
class and implementing runnable methods.
Implementing run.
Which one is better?
Runnable one.
Runnable one is better. Nice. And yesterday, what we talked about daemon thread, non-daemon thread, right? Parent-child relationship. And in last, we talked about synchronized keyword. That is very important. So guys, you need to know if you talk about concept of lock, we have two kind of lock. I don't know you know it or not. One is called class label lock. Second one is called object label lock. RAM. So question is how this lock, right, is associated to each other. So we have class label lock. Hmm. Every class in Java will have how many lock? Every class will have only one lock. What about object? Every object will have only one lock. Ram, do you understand this concept?
Yes, sir.
So how you'll come to know when a thread will take what lock? Class label lock or object label lock? People, class, help me. Here, if your method is static, Ram, then you have to take class label lock. So tell me, if any thread wants to call foo method, thread has to take any lock? Answer is no, because this method is not
Static.
synchronized,
Synchronize.
right? Now your method is synchronized. You have to take object label lock or class label lock. Any guess?
Class level.
Class label lock. And if you make this method non-static, this question goes to you. Then you have to take
Yes.
object label lock because this method belongs to object and this method belongs to
Class.
class. So I have a question. Suppose we have two thread, right? You see, assume Ram, this question goes to you. Suppose at the time T, this thread is calling this method, right? At the same time, thread 2 can call this method G at the same time. Yes, you know. Ram, think and tell me.
No. No.
How many people are saying no? If T1 is calling this method at time T, at the same time, do you think T2 can call this method G? People reply.
I guess no
I
too.
replied no.
Okay.
Yes.
Somebody is saying yes. Who is saying yes?
Uh,
Answer
So
is two people already said yes, right? The next answer is hmm. Okay. Go ahead. What are you saying, man? Be fast.
one is calling foo and one is calling z, or like.
Yeah. One T1 is calling foo at the same time. T2 is trying to call Z. So T2 would be able to call Z at the same time the moment T1 is calling foo.
No.
Yes.
Saying yes, my dear friends, just be fast.
Yeah.
I think yes, Nagin.
Okay. Okay. Why? Yes is the right answer. Reason? Reason is if T1 wants to call foo method, T1 needs what kind of lock? Class label lock. And T2 at the same time needs object label lock. Ram. Because
Yes.
when T1 is accessing foo, that time only class label lock is used by T1. That time object label lock is free and T2 can take it and execute it. You got it? But if you make this method static, Ram, then answer is
No.
answer is no. Why? Because both methods are static. To call both method, thread needs class label lock, and there is only one lock for the class, right? So if T1 is calling method foo, at the same time T2 cannot call method z. This is clear, or you confused?
Clear.
In this case,
Clear.
can I say T1 and T2 cannot answer to me, cannot call foo and z
In Z at the same time.
at the same time? Nice. After teaching this much, if you are not able to answer it, that's very bad. So we have two kind of log, object label log and class label log. Please remember it. If a thread wants to take class label log, what thread has to do? Thread has to call synchronize and static method. Remember it. Is clear, people? Okay. Now I am trying to teach you concept of Java stack. Interesting. Let me give you some example, right? People, you can help me. Yes. You need to understand what is the Java stack. Java stack is a memory. What, man? Java stack
Memory.
is memory, and this memory is a special memory and it is associated with only thread. So let me tell you, Java stack is special memory. Every object has Java stack? No, 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 no. Java stack is special memory which is part of only thread. Got it? I have one thing. You have to just tell me. Uh, every thread is an object. Every thread is an object. You have to answer it. Yes, you know.
Yes.
Yes. And every object is an thread.
No.
Every object is a thread. Answer is no. Please remember it. So Java stack will be only part of thread, and this Java stack is a local memory of a thread, right? Only that thread can access it. So let me show you uh, what kind of memory is allocated to the thread. Do you know a little bit about Java virtual machine? Let me show you.
JVM.
Techno hunk. I'm just, I'm just opening this diagram. I'm going to show you the block diagram of a Java virtual machine. You know what Java virtual machine is? Java virtual machine is a special machine which is responsible to execute your Java program. Do you know what I'm saying? Yeah. So at one computer, how many Java virtual machine you can create? Any guess? One or multiple?
One.
One. Anybody else wants to try? At a computer, how many JVM you can create? RAM?
One.
Multiple JVM, man. One Java command can create one Java virtual machine. Guys, if you say Java A, one JVM will be created, and that JVM will execute which class?
Yeah, class.
A class. If I want to make a 5 JVM, what you need to do? You have to run the same command how many times?
5 times. Five
5
times.
times. So you can create how many JVM at a computer? As many as you want. Clear? Done. So this is the typical diagram of the JVM. So every JVM contains Java heap, method area, Java stack, native stack, program counter, just-in-time compiler. This is the typical diagram of Java virtual machine,
JVM.
JVM. So you need to know in these all are the memory. You need to know in which portion of the memory what data reside. If you make an object using new operator, this object memory is allocated where? In Java heap. Guys, you are not replying.
Yes, sir.
Java heap. If you create any instance variable, right? Class dog. Instance variable will be located where?
Method area.
Java heap, right?
Yeah.
And static variable memory is allocated. Some now you can answer it. Static variable memory is
Stack.
allocated to
Stack.
method area.
Method area.
Hey guys, you need to know what memory will be allocated where. This is allocated inside Java heap, and this is allocated inside method area. So what memory is allocated to the Java stack? And Java stack is a part of object or Java thread, Java, thread object, not normal object. If you make a class, Noor, are you there?
It was here.
I just wanted to know when you are taking my session, that time what you are doing? You may be making tea and coffee.
Dinner,
Hmm?
I guess.
Dinner? Very
In
bad.
evening time. That's why.
Oh, no, man. Don't reveal all those things, right? This is open secret. Public, wide, foo. Like here, if this X is called local variable, Vishal, X is local variable or not? This question goes to you.
Yes. Yes.
Okay. And what about here? This is called instance variable, right? Integer X. So X, this X will be created where? If I make an object of Noor, then X will be allocated where? This question goes to Vishal.
Java heap.
Java heap. He's right. And see, but when when you call this method foo, right? Local variables memory is allocated inside Java stack. Nice. So this X will be allocated where?
Method area.
Stack.
No. This local variable memory will be allocated on Java stack. Do you understand? Yeah.
Yes.
Oh man, what I said. This X, right, will be allocated. Why? Why on Java stack? Who will tell me? Because it is local variable. And local variable of the method memory will be located on Java stack. An instance variable, Vishal,
Heap. Heap,
Mm-hmm.
heap, heap.
Java heap. Understood or not?
Understood.
Yes.
Okay, that's great.
Little bit confused on the method area.
Method area actually holds class detail. You know class? When you make a class should be also loaded in the memory or not?
Yes.
Then
Yes.
here we have two things. Class plus object. Memory will be taken by two things, right? Who will take the memory? Class
Heap
definition.
and stack.
Class definition, right? When you make the
Mm-hmm.
definition of the class, this class definition will be stored where? Method area.
Method area.
This method area after Java, since Java 8, it is called meta space. Please remember it. Okay.
Okay.
But class definition and static variable, where memory is located?
Method area.
Method area. I hope you understand Java stack. See, actually, I told you right in previous session, every method is called by whom? Thread. You know it.
Right.
Mug it. Method is always called by
Thread.
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 Thread. So when thread call a method, this local variable memory will be allocated on that thread stack memory. Every thread has a stack, and this Java stack is local to it. Whatever memory is allocated to the stack, nobody can share it. And this stack is a collection of Java frame. Oh man, this Java stack is collection of what?
Java frame.
Java frame, and each frame will represent a method. Nice. Java frame, and each frame will represent what? One method, right? You got it or you got confused?
Got it.
I'm just making the diagram of Java frame, a Java stack. So all together, this is called. Please, if you confuse, you should say I got confused. No confusion at all. You guys are following me, right? All together, if you talk about all these three color, it is known as
Java stack.
Java stack.
Java stack. Nice. So Java stack is a spatial memory which is allocated to only thread. Can we define the memory size of it? Yes, you can do it, right? How you can define the Java stack memory size? When you run your Java program, how you run the Java program? Using Java command. So then as a VM argument, you can use this option. For what purpose? People reply. You can use this option -x for what purpose? To
Memory
give the
control.
initial size to. This question was asked many times in the interview. What is the Java stack, right? And can we define the size of it? Yeah. You can write SS. I'm sorry about it. XSS, and you can give the memory here. Like you want to give 4 MB. And then you can write the people. Then you can write your program name. Suppose your program name is test. If you got it, say I got it. So this is VM argument to define what, man? Size of the Java stack. People. Is clear to you? Yeah. Reply. Can I jump to the next?
Why we have to like give the size here?
If you want to make a bigger size, by default it may be taking 4 MB, but you want to give it 8 MB, 16 MB, you can give it.
Oh, okay.
Otherwise, sometime what happen? Your Java stack memory may be full, and you can get an error that is called, j- stack overflow error. Which error?
Stack Overflow.
Sometimes you get this error.
Oh yeah,
If
yeah,
you
Stack
if you
Overflow.
want, I can show you this error right now.
Mm-hmm.
Somebody is saying yes. Could you please generate this error and show to me? Yeah, I'm going to show you which error, man.
Stack Overflow.
Stack, stack overflow.
And again, Stack stores the data like is based on last in, first out, something like that.
Yeah. Actually, stack is a data structure. So in this Java frame is created on the fly, right?
Mm-hmm.
So it will follow first in, first out principle. That's correct. In, first out. The frame which will come first in the Java stack, right? That will go first out, right? Is follow first in. No. Is follow
Last in,
last
first
in,
out.
first out. No. LIFO. Last in, first
Life,
out
yeah.
principle. The frame which comes in the last, that will be pop up first. It will go out first, right? Last in, first out. Got it? Okay.
Yes.
My dear friend, you want to see which error?
Java stack overflow.
Yeah, overflow error. You do one thing, you just make a recursion call. What happen if one method call other method? Hello? It is not going to be terminated. Main is going to call main, right? So when method call will happen, it's going to create a memory in Java stack. I told you, right? Method, whatever memory allocated to the method, where memory is allocated to the method, it is allocated to the Java stack. Are you following me? So if you call a same method again and again, infinite call, then after some time it would say, hey, my stack is full, and you'll get what error?
Stack overflow error.
Can you see this? Yeah. No? I'll kill
Yeah.
you.
Mm-hmm.
Why? Because when one method calls other method, it is going to save that method memory in Java stack. So this in this case, right? Which stack is full? Any guess? Stack of main thread. Stack of main thread.
Main
Why?
thread.
Because this main method is called by whom? Who calls this method?
JVM.
Calls
JVM.
this main method. No. Answer is who calls this main method? Answer is main thread, right? And who creates main thread?
JVM.
JVM.
Who creates main thread?
How
Answer
that
is
becomes
JVM.
full? Does it have like memory limitation?
No, man. By default, it would take that much size, right? It's not a
Okay.
hard and fast rule. You can customize it as per your need.
Okay.
Okay. Let me give you one interesting situation, and you have to answer to me, right? I'm just making a program. This is interesting. This is again one of the most frequently asked interview question. And I'm telling you, if you don't know multi-threading, you will do mistake, right? I'm making a class, and my class is loader. And in this class, I have a public void main. Sorry, public void foo. Confused? No.
I
In
heard in any
this,
banking interview they ask multi-threading. Any banking interview. I don't know about others, but I
no
heard.
problem. You see, I'm just making this program, and I have x variable, and I'm just incrementing the value of x by 100. Okay. So you have to tell me, right? And then I'm calling system.out.println. Okay. And printing the value of x. And you have to tell me the output of it, right? If this question goes to whom?
200.
Yeah, you have to tell me the output of it. See, this method, this method can be called by one thread and maybe multiple thread. The first situation I'm giving to you. Suppose it is called by one thread only, right? One thread is there, and normally it happens to you, and this is called by one thread. Then what is the output of it? End of the day, Ram.
Yes, sir.
What is the output of it?
200.
Simple, 200. Suppose same method, right, is called by two thread at the same time. Both because we don't have synchronized method, right? So both
Mm-hmm.
thread will go inside. So tell me, output will be going to be impact or not,
Yes.
Yes.
right? So tell me.
If one method is calling multiple time without synchronized
No, 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 no,
keyword,
no,
so
no, no. I'm not talking about synchronized keyword right now.
Mhm.
I'm just saying, assume T1 and T2 both are going to call. Even I'm just going to make one more thread. Three threads are calling this method at the same time. They are entering inside the same time. So each will print 200, 200, or output will be mixed. Think and let me know.
Output could be anything.
Your see, if you cannot predict the output, this condition is called race condition. So this would be race condition situation or not?
Yes.
Race condition means you cannot predict the output of it. Hello, guys. So according to you, you cannot predict the value of x. Am I right? Because T1, T2, T3, all three threads are calling the same method at the same time. Make sense?
Yes.
Ram and other people reply yes or no.
Yes.
Yes, sir.
Okay. But let me tell you, I just talked about, right? T1, T2, T3 are thread. So every thread will have its own Java stack. Ram, what I said? Every thread will have its own Java stack. You forget the concept, right? And I told you, every thread, this thread has its own Java stack, this thread has its own Java stack, right? So if all thread are calling to it, and this method has all the variable local to it, Ram. So what happened? See, when T1 is calling this method foo, then X will be allocated to the particular stack of it. Ram, think the way I'm thinking, right?
Mm,
This is Java stack, right? Every thread will have its own Java stack. Say yes.
yes.
So what happened? This local variable, when this thread will go inside, right? Then X will be allocated to the Java stack of it, right? Which is local to this thread only. Same thing will happen for this also. So every method, every thread will have its own copy because of local RAM. So all are going inside at the same time. That's correct. That's correct. But all will have their own copy of it. RAM. So because of local, it is not going to put any impact. What happened, man? This thread goes inside it and it is creating own copy of it. Then it's incrementing the value of X in own copy of it and printing the value of X. What? After incrementing the value of X by 10, it will print 200 RAM. This will also print 200. This will also print 200. No problem at all. Why, man? See, if you see, conceptually just code, so you would do mistake, but it is not going to put any impact. If all the three thread will call at the same time, all the variables are local. So first of all, this thread is creating its own copy, 100, and incrementing the value of it. All are making local copy of it, and they are incrementing the value where in local copy or global copy?
Local copy.
Local copy. So tell me, if they are incrementing their value in the local copy, do you think it will put any impact? No.
No.
Basically, because of local variable, they are making changes in their copy, which is in Java stack. So what is the output of it? 200, 200, and 200. So guys, if somebody is asking this kind of question, just be careful. Ram, your question may be, Nagin, can you show me the example of it? I can do it, not a big deal. But you got this
Yes, sir.
concept?
Yes.
So a why problem is not coming because local variable will be created on calling thread Java stack. This memory will be created on Java stack of what? Ram,
Java stack
Java
heap.
stack of calling thread, right? Let me
Mhm.
write it. X will be allocated on Java stack of calling thread. Confused or you got my point? Guys,
Java
you're not
stack.
replying. X will be allocated on Java stack. So if you have three thread, how many copy of X will be there? Not replying. I said
Only
if you
Three.
have three
We have
thread,
three.
three
there would be
copy.
three copy of it, and every thread is making change in their own copy. So there would be no conflict. There would be no race condition. Got it? Let me change the program. What I'm going to do next? Ram, same program. This X, I'm just making it global, not local. Then problem will be there. Why? Because all thread are going inside it and they are trying to make the change in the same copy of it. Why, man? This X will be not created where? RAM. It is not going to create in Java
Stack.
stack. X will be created now.
In instance variable.
Java heap,
Java.
right? And Java heap data is shared, right, across all the thread. In this situation, race condition will be there or not?
Yes.
Reply. In this, can you predict the output of it? Answer is sleeping people. Answer is it is not going to.
No.
You cannot predict the output of it. Why, man? Because X is a shared variable and all the three threads are going to increment the value of shared variable. So in this case, you cannot predict the output of it. You tell me both the programs are clear to you or you got totally confused?
Clear. So right here, I have a question.
Just a second. Here we cannot predict the output of X. So this is called race condition. Yeah, Ram, go ahead.
So when we are making the like a model entity class, right?
Mhm.
over there we have an instance variable which is stored in the Java heap, right?
Java heap, that's correct.
That's why we are not calling. We cannot use in the other classes, right?
Hmm.
But when we uses that properties in the other class by auto-wire, so creating the object of that, so it will be affected or not.
No, no, actually you can think about it. There in service layer and DAO layer, you would never see the instance variable. We always have local variable. You can go and check it, right?
Mm-hmm.
And I'm telling you, those classes does not have any instance variable. You can go and check it. If you have instance variable in the class and that is shared, you'll be in trouble. Ram, you will never see any instance variable. If you see, let me know. Okay.
Okay.
Entity class is a different thing, man. Entity class does not have business logic. It is used to share the data. And in every call, there is a new entity class is created. Okay. For every call. We'll talk on that. Okay. This must be clear to everybody.
Yes, sir.
Yeah.
No, yes.
Yes,
So
sir.
you understand both the diagram? This
Yes,
diagram
sir.
Yes.
is not going to cause any issue, but this is going to cause issue because this is shared variable, right? Done. Okay. So guys, do you know
Nag,
run? Yeah, please.
just a quick question. Can we have a duplicate value with stack, or I know there are a lot of questions coming up, like duplicate, or like let's say if you find a size of something, how would we do that with stack?
I don't understand what you're saying.
Can we
Sorry.
I say like with Java stack, I was saying can we allow duplicate with
Yeah, of course,
Java
man.
stack?
It could be anything. In Java stack, every frame contains local variable of a method. Are you following me? Suppose
Mm-hmm.
one method is you have M1 method, right? Main is calling M1 and M1 is calling M2
Mm-hmm.
and M2 is calling M3. So you know what M1? M1 actually represent the data allocated for method 1. M2 represent to data allocated to method 2. M3 represent data allocated inside method M3. Are you following me?
M3. Yeah.
So in Java
Okay.
stack, whatever frame you have, every frame represent memory allocated to particular method. Are you following me? So
Yes.
you tell me. Suppose we have main, right? Main
Yes.
method is calling M1 and M1 is
M1,
calling M2 and
M2,
M2 is calling M3.
M3,
In this situation, how many frame will be there in a Java stack? 4 frame. One is for main. Let me
and three
represent it.
others. Yeah.
So here you have to make a 3 block and every block will represent one method invocation. Are you following me? And how you can
Mhm.
represent it over here? M1 will be main will be on bottom. Are you following me? Because this is the first method which is called by JVM and sorry, which is called by main thread. Then M1, then M2. Are you following me?
Yes.
So once your M3 method execution finished in reverse order, it will be popped out. M3 is completed, it will be popped out, and result will be returned to M2. Then M2 is completed, and result returned to the M1, and M2 will be popped out, and so on.
Okay.
I hope you got
Cool.
it.
Thank you. Yeah, I
So
got it. Thank you.
Java stack is a memory allocated to the all the method invocation, and in this Java stack is a collection of frame, and every frame represent memory allocated to particular method. Clear?
Okay.
So this is collection
Yes.
of Java frame. Done. This is enough, guys. Let's talk about Runnable. Yeah,
Yeah, runnable
Runnable is what?
interface.
Runnable is basically interface
Runnable is the interface. Right.
which
Yeah.
is used to
It's
make a
interface.
task. Already I had shown you the example of it.
Yeah,
So
it's
let me show you
functional
the example
interface.
of Runnable, and we will talk about Runnable limitation. So
Mm-hmm.
if you want to perform some task, you have to make a class that is called Rona extends Runnable. So Rona is what, man? Rona is a runnable task. Okay. And what you want to do, you want to perform some law task. You have to override which method, Ram? Vishal. Which method?
Override
Run method.
Run method.
Override. And here you can say for what man?
For I
Integer x 1.
is equal to
It
1.
is going to say something, right? 100 x plus plus. Confused? No at all. System dot
Without
out
X.
dot println x is from Rona and its value is plus. Clear? So this is runnable task. Hey, what is the limitation of this task? First limitation of this task is if this task is completed, it is not returning any value. Ram, what is the first limitation of runnable task?
It is not written any.
If this task, first limitation, let's talk about first limitation. A, do you understand what I'm saying? This task does not return
Return.
any value. So your requirement is once task is completed, you want it to return some value. It's not possible. Second, second problem is this in this you cannot throw any checked exception. Second limitation, Vishal. Ram, what I said? Second
You cannot
limitation.
throw any checked exception.
Yeah. Second limitation, this runnable task cannot throw any checked exception. It can't throw any checked exception. These two limitation you have. And both you can overcome with the help of another interface which was introduced in Java 5, which is called Runnable. Oh my God. What is the beauty of Runnable interface or sorry, what is the beauty of Callable interface over Runnable? Ram, Callable is introduced in Java.
5.
This is also marker interface and it was introduced in Java 5, Java 1.5. What is the beauty of it? This task will return some value and you can throw checked exception also. So this is again one of the interview question. What is the benefit of callable task or what is the hello benefit of callable task or anybody have any question query? You guys are not replying.
Again,
Hello.
so they both work the same, callable and runnable. Like they both work as a task.
Yeah, both are used to create the task. I'm going to show you use of callable, how you can use it instead of runnable. True. Clear?
Yes, clear.
Hello. See, in Java 5, there is a new framework was introduced that is called concurrency framework. I have a question for you, Vishal. Right now,
Yes.
who's you you tell me in every program who is creating
Uh-huh.
thread? You are creating thread using new operator. Say yes.
Yes.
So in Java 5, concurrent framework is introduced. Concurrent framework says you do not create thread and all. Don't do this, right? I'll create thread, I'll assign task, everything I will do on behalf of you. Oh my God, magic. So which one is good to do? Creating thread,
Uh,
assigning task to it, starting it, or it should be managed by somebody else? Let me show you the
Managed by
problem.
somebody else.
Somebody else.
Nagin,
Just a second. Just a
uh,
second. I'm coming to you. Here, let me tell you what is the limitation of this program. Limitation of this program is you are creating the thread, attaching task to it, and you are starting it. You are managing it, right? Everything is done by the programmer, right? So in Java 5, a concurrency framework is introduced, and that framework says, hey, you don't do all this thread creation, starting the thread, killing the thread, stopping the thread, all these things you should not do it. It is done by automatically framework. So what you have to do, you just create a task and just submit to the framework, and framework will take care of it. Nice. So what concurrent framework is going to do? It is going to make your job easy,
Easy.
smooth. You can go ahead.
yeah, I was just asking about Callable and Runnable interface. So I think you said Runnable does not return any value. And I heard, I don't know if that's right, Runnable also does not throws check exception. Is that right?
Yeah, I just mentioned over here. It cannot throw any checked exception. Both the
Oh,
point
okay,
already I
sorry. I
mentioned over
didn't.
here.
Okay, sorry. I didn't.
So guys, I'm going to show you a concurrent framework. What is the benefit of it? It will make your job easy. So this is the first program. Can you see this? If you want to make a pool of the thread, right? Hey, what is the benefit of a concurrent framework? Let me show you. In concurrent framework, you can make a pool of the thread. Oh, nice. How to make the pool of the thread? Creating pool of the thread. Ram, do you understand what I'm saying?
Yes, sir.
You see how your programming is going to be easy. If you want to create the pool of the thread, you have to use the executor and this factory method. Ram, you see, this statement will create a pool of the thread. And in this pool, how many thread will be there to serve your request to execute your task? People reply. This statement is going to create a pool. And in this pool, how many thread will be there? Any guess?
3.
3. So basically, it will make your multi-threading, programming easy because you have to just write this line and 3 thread will be created, right? So question is, if 3 threads are created, how you can communicate with this thread? You can communicate with this thread with the help of some predefined interface. What that interface is, that is called executor. Oh, nice. So, 3 threads are created. Am I right? Yes.
Mhm.
You got my point? T1. But these threads are not doing anything, right? You have to assign some task to it. These are the blank thread. They are not doing anything. Ram.
Mm-hmm.
So how you can access this thread pool using executor interface? Can you see this? Hello. You want to assign the task to it? How? Guys, you have to make a task. How to make a task? You know? If you want to make a task, you have to either implement runnable or callable. It is up to you. Ram, come with me.
Callable.
Like here, I am making task with the help of runnable. That's it. So, this you understand, or shall I explain you again? No, this is just normal task, which is printing the task name how many times? 100 times. People reply. Confused?
No.
Executor.next fixed thread.
Let me make a very simple program. Like here, I want to make a task, and this task you want to execute how many times, Ram?
100 times.
100 times. That's fine. Uh, this task is task. You can write task E. Similarly, you can make another task. Allow me.
Go
This is
ahead,
task
sir.
B. And here you can say task BX. Let me make the font little bit smaller. Can you see this? So we have task A and task B. You want to submit to it. You can use this framework name. It could be anything. EXE. You tell me it is super easy, right? And here you can use a method that is called execute method. Ram. And in this method, you can pass the object of the task which you want to execute. Task A. Tell me your programming becomes simple or not? That's it. Now, how many tasks you are creating, man? 2 tasks.
Two
So
tasks.
when you submit to it, right? When you submit to it, execute it, it will go to the thread. This thread pool has a thread queue. It will go to the queue, right? Both the tasks will come over here one by one. Ram. Automatically, it will be assigned to the running underlying running thread. You got a point? So this
Mm-hmm.
task A will be assigned to one thread and this will be assigned to the another thread. That's it. But tell me, you are doing any programming to create a thread and assigning tasks to the thread? No. you have to just call the simple method, right? You do not have much overhead. I don't know, you got my point or not?
Yes, yes.
Yes.
So this is called concurrent framework. This question again, it can be asked in the interview. What man? What is the concurrent framework and what is the benefit of it? What is the concurrent framework?
It
So do you
automatically
understand the
creates
benefit?
the thread and makes our life easy.
Yeah, exactly. Nowadays, everywhere people are using this also. People are using only this, right? Because if you do it programmatically, manually, it will take a lot of time. It's a lot of overhead as well, right? But this concept, thread pool concept, makes your job easy. Okay. So you can make call, you can make it with the help of Runnable, and you can make task with the help of Callable. So let me make a task with the help of, hello. One task I will make with the help of Callable. Second, I will make with the help of Runnable. Guys, if you allow to me, I can take this task, right? Then Callable task, sorry, Runnable task. I am going to make another task. Vishal, how?
Mhm.
Task C implements
Callable.
Callable. When you use Callable, here you have to pass the return type. What you want to return? String, what? Integer, float, double,
Integer.
integer. So you can write here
Boolean.
integer. It is up to you, man. And here you have to override a method public return type integer. Whatever you will write here, same thing you have to write here. And method you have to override is call. Ram. Done.
Dot override.
Dot override.
Forward D.
Override, right? So
Mm-hmm.
what you want to do against this method, it is up to you, right? But you have to return some value for sure. So again, I want to run a loop. Teaser k equals to 1, k less than equals to 20, k plus plus. Ram integer
Mm-hmm.
sum equals to 0. Basically, you want to sum all the value plus k.
K.
In last, you have to return it, right?
Return K.
Yeah,
Return
return
sum.
return sum. So this is again task, but it must return some value in the last. You know it exactly. Fine. So I am able to make how many tasks, man? Two tasks, callable task and
Runnable
Runnable
task.
task.
runnable task. Now you want to execute these two tasks against the thread pool. You have to make a pool, and I'm telling you, there is many way to make the pool, right? Here, if you want to use a runnable task, right, then you have to use same thing. Everything is same, but left side you have to use executor service because executor service interface has that capability. Can you see this? Hello. What I'm using right side, left side,
Executor
executor
service.
service. This interface has capability to submit callable task as well as runnable task. So here you have to use a method, submit method. Which method, man? Submit.
Submit.
In previous example, we had execute method, but submit method you can submit both the tasks. New task A. Confused? No. And you can submit which task, man?
Both task.
Task C as well. And whatever output is returned by the task C, how you can hold it, I'll show you tomorrow. You got this much, and you totally got confused.
Now
And
I
after
can see.
that, you can just mention shutdown. Shutdown means you want
Stop
to,
killing.
yeah, you want to stop the pool because you don't need any more, right? Your job is done. So in last, you have to do shutdown. Shutdown means once all the thread tasks completed, you don't need this, right? So you can do shutdown. You got this much? In next session, hello, we'll talk more about it.
So
Just
right here,
wanted to know. Tell me. This code you have to write inside the main method. Man, if you want to write complete program, where you have to write this code,
inside the
you have
method.
to, yeah, you have to make a class. Class is wrap tray tag, right? And in this class, you have to write what method, man? Your favorite method, public static void main. Mhm. And here you can write string
String args.
main, right?
Mm.
Done. After this, hello, end of the main and this. Now this is complete program. I hope I'm making myself clear.
Mhm.
Please go and make your hand dirty. Just wanted to know in last, whatever I have taught you so far, do you understand everything?
Yes.
Yes.
Okay.
So
So my friends, today just want to tell you what we have done. Today we have completed one of the important concept of multi-threading Java stack. And before Java stack, we talked about what is the JVM architecture or JVM block diagram. What are the different component of JVM is, right? So in JVM we have Java heap, method area, right? And today in discussion we have done Java stack, right? So we talked about what Java stack is. Clear? And in this, in order to support this concept, I had shown you the concept of local variable. In method, when you make a local variable where memory is allocated to it, I explained to you that, right? If you make local variable, what happen? If you make instance variable, what happen? We talked about. Yes, you know. So I have given you the example of both local variable and instance variable. This is the local variable and this is the instance variable. Make sense? And after it, we talked about another popular interface which removes the limitation of callable, that is, sorry, which removes the limitation of runnable, that is called callable. Make sense? Then in last we talked about concept of concurrent framework, right? How you it improves your programming experience using concurrency framework, and you have seen the benefit of it as well, right? So in next session we'll talk about more concept about multi-threading. I will discuss what volatile is, what is the atomic integer, what is the concept of reordering, right? So still I have a lot of concept to explain to you. Okay, I think this much is enough for today. I'm just stopping my session here. Thank you so much for your time. See you tomorrow in next session. Thank you.